As I've mentioned in other videos, right now the MIAP objects don't support GUI map authoring. There's a scripting language that lets you author maps, and I'll briefly point you there. So there's a little subpatch in the MIAP and MIAP-tilde-help files that says map authoring. And there's a full language to create nodes, delete nodes, create trisets, delete trisets, and so on, edit different properties. And then that will dynamically create maps. So there's a kind of message language. So let me try show you an example here. If we move this over. So that list of messages just created some nodes, 3 speaker nodes and 1 virtual node. That message created trisets, and that established the links. So now I've got a simple map. So there's functionality to support making maps in Max, but and it's something that could be very useful for a more advanced Max programmer. But in general, it's more intuitive to author maps with a GUI using your mouse. And that will be functionality that's supported in the future with my object. But for now, and even in the future possibly, you may prefer to use MIAP's software for that. So I have a link on my website to CueStation, MIAP's CueStation software, which is the control software. It's client software for their Dimitri and Matrix 3. Matrix 3 is the old version of Dimitri show control systems. And one part of that software is SpaceMap. So an easy way to use CueStation is to download it, use the links that I provided on the website, rename it SpaceMap, like that. And then what I'm going to do here is I'm going to walk you through authoring a map in SpaceMap, saving it, and then importing it and converting it to the correct file format and importing it into the MIAP objects in Max. And the same thing exists in PD. So let's open up SpaceMap. So the first thing, it opens up a SpaceMap window, and it also opens up a connection manager. We have to launch Virtual Dimitri, which also comes with that software. That will just launch a virtual server. The server is normally housed on the Dimitri hardware. And then after that you can minimize it and you're done. So from there, now you can open up a project. And I provided a project, so press Command O. I provided a project in the package, both an example project and a template project that is pretty empty. The example one has all the maps from the example MIAP help files. Let's open up a template, and we're going to make our own map. So then you see a SpaceMap window, much like the GUI map in Max. So we've got a bunch of speaker nodes here, and I'm going to not talk about everything here, but we're going to author some maps and save them and play with them and see what happens. So this is the place that I like to author maps right now. So right now we've got a bunch of different mouse modalities. This one is just, this arrow is just for selecting and moving objects around, nodes. You can highlight the entire thing and move it around. That's what that's for. Selecting it and then right-clicking and changing different properties like the type of node that it is, speaker, virtual, derive, silence. You've seen that in the other videos and documentation. Set which output it goes to, and this project is initialized to have 120 outputs. You can set the trim for each node, which is not displayed graphically here, but you can see it defaults to 0 dB. I display that in my object, and then some other stuff. So let's first thing we want to do is, if we click the headphone, you can see up here you've got a row of this is a row of buses or output channels that these nodes represent. So if I mouse around, you can see this is a bus. It says bus. If I mouse around in here, you'll see the gain values. Even though you won't be able to hear it, you can see the resulting gain values, similar to the list of values that's outputted in the Max MIAP object. So you can see that as I'm in the center here, between channels 1, 4, and 5, so you get a mix of 1, 4, and 5. If I go right on top of channel 1, it's almost 0 dB, and then very low in the others. So that's your way of kind of auditioning what's happening. Let's make a new map from scratch. So forget trajectories for now. That's for more advanced use. You can author 2D trajectories, and there's also functionality in the MIAP patch to do that. Check over on the right-hand side of the patch. We've got 2 different maps here as examples, but let's start a new one. So click on SpaceMap A and new SpaceMap. You can name it whatever. And now we've got a blank SpaceMap. Now this is the ID. You'll need this later. You can see how they each have number IDs. So this is ID 2, which we'll use when we're converting it. So now let's make some speaker nodes. So I click on this speaker icon, which says Add Speaker Nodes. And let's make a first thing let's do is let's make a 4-channel system in clockwise order. So I just clicked and it incremented the channels. If those weren't correct, let's say that this was wrong, or I want this to be channel 5. I go back to the arrow here. I right click on this guy, set output, switch it to 5. Okay, so as I mentioned before, each of these nodes has a trim, and you can set these in dB. Now let's say that I want in the middle, I want a virtual node. The next one over is virtual nodes. So let's say we've got speaker nodes, virtual nodes, Derive nodes, silent nodes, and then this is the button you press to create trisets, and this is the one that you do to audition. So let's make a virtual node in the center, somewhere in the center, right around there. It's not quite the center. And then let's make the trisets now. So I click on that, and you can see as I mouse over, it tells me that it shows me the different options. I don't have very many choices here because of the way I've aligned the nodes. So let's make trisets just like that. If I want to get rid of it, click on it again. Easy as that. And now I've got a quad space, excuse me, right? And if I click headphones, I can audition that. Now there's a problem here. The virtual node is in the center and it's part of a triset, but that virtual node isn't linked to anything yet. So notice you've got 1, 2, 3, 4, but when I'm here, this is a triset of 1, 4, and a virtual node. You see there's only gains on 1 and 4. That's because this virtual node is acting as a node here, forming a triset, but the gain associated with this is going nowhere. So what we have to do now is highlight this node, and then highlight at the same time all of the other nodes. You can press Shift and click each one of them, or you can click and drag everything, whatever you want. Highlight the virtual node, and then highlight the nodes that you want to link it to. And in this case, we're going to link it to all 4. And then right-click or control-click, link virtual/Derive node. Now they're all linked. You can see that you've got a red line over the black line here, or over the blue line. And that, by default, it does a power preserving and in equal weighting of all of them in 0 dB. In Max, in the Max version of these objects, you can choose whether to display this as dB or linear amplitude, and it defaults to linear amplitude, I believe. But we can change this. So let's say that we wanted, the proportional weighting. We wanted these to be weighted half as much as half as strongly as the bottom two. We can click those, click all 3 of them, and then control-click, set virtual link gains. And let's set it to, let's say, -6 dB. There. Now it's -6. So let's audition. So I click on the headphones, moving around. Node 1 is very strong, 0 dB. Node 2 is 0 dB. Now if I go to this one in the center, right in the center, you can see that it's attenuating each of those by 6 dB. Basically, this is -10, -10, and -4. So it's doing a power preserving mix, but weighting the bottom speakers more. So that's something to consider, the weighting, but the most important thing is making the virtual node and then linking it, right? So let's add some silent nodes. So that's this guy. Actually, let's add some Derive nodes. That's the next one over. If you mouse over, it says Derive nodes. So a Derive node is another physical output. Let's add 2 Derive nodes, like that. 5 and 6. You can change the outputs. If I want this to be 7 and 8, I can do the same thing here again, set output. Derive nodes have to be linked to speaker nodes just the way virtual nodes do. The difference is they don't belong in a triset, right? So let's highlight this Derive node and link it to the bottom 2 speakers. I highlight everything, control-click or right-click, and then link virtual/Derive nodes, just like with the other one. Now this, by default, does a 0 dB attenuation, and this isn't a power preserving mix the way virtual nodes is by default. This is a linear summing. You can change that, not in the MIAP software, but in the Mac software. You can change this to be power preserving if you want to. So you could change one of these gains. Let's say, just for the sake of argument, I want to change the derived gain, make that one. Actually, let's change them both and make them both 3 dB, -3 dB. There. Okay, now I will highlight the top 2 and click link virtual/Derive nodes, and also then, while it's still selected, set the link gain to -3. There we go. Now let's audition again. So now I've got, you can see no matter where I am, when I'm over here, I've mostly got the power in 6, -3 dB. with minus 16 dB for node 5. And there's still something there because this virtual node is one of the 3 nodes in this triset, and the virtual node is grabbing signal from 3 and 4, and 3 and 4 are linked, 5 is deriving its signal from 3 and 4. So there's still some signal coming from the other side. But if you watch 5 and 6, as I pan down, 6 is going to get stronger and 5 is going to get weaker. All right, so the last thing we're missing is silent nodes. So let's click on the next one, silent node. And for this one, let's just add some silent nodes around the rings here. Do something really quick like this. And then silent nodes are also have to be parts of trisets, so let's do that. Make some trisets. I need another silent node on the corners like this, just for now. You see how much easier this is to make a map than to script it, unless you're doing something algorithmic. So there we go. So now I've got silent nodes, and I can audition, move around, and then I have a fade out space. Where if you look at the gains up there, they're getting softer and softer and softer and softer until I go to nothing. So that's a simple quad map with a center node. Let's just say we want to import this now. So save the file, and you can save to a new file if you want to. You can go to project. I'm not sure why that's grayed out. Let's see if we can save. Yep, it let me save. So Command S. I'm not sure why that's grayed out right now. That's probably something simple to fix. Anyways, the shortcut is Command S. And now I will hide that for a second and go over to the MIAP object and open up the GUI window. And let's load in, sorry, skipping a step. So now what we have to do is we have to take that project file and we have to convert that map, which was ID2 if you remember, load it in. So I have the MIAP.meyer external. That's an external that the sole purpose of this external is to load in project files, grab different maps and trajectories and save them to different files, to map and trajectory JSON files. So let's load the project. This one. Okay, so we just loaded it in. If we look at the max file, automatically when you load a project, it automatically loads in whatever you set these IDs to. It's going to try to load it in. We don't have to reload this project, by the way. If I were to open up that same CueStation software and save the project, I wouldn't have to read the project in again. I just can reload, switch the index number on the map or trajectory, and it loads from disk. It remembers the name of the project. So anyways, when you load something in, it will tell you whether it successfully read the map or not, or the trajectory. So let's set this to 2, and we can see that it successfully read it. Now I'm going to write the map. It's right to the desktop, and this is test quad. And it wrote it, and now I have to load it into the max object. And I'll go to the desktop, load this in, set it and read it, and there it is. Now I've got a map. Channel 1, Channel 2, Channel 3, Channel 4, virtual node. You see the derived nodes are 5 and 6. 6 is on the top, 5 is on the bottom. And that's it. So you author it in SpaceMap, save it, load it in to MIAP.meyer and save it as a JSON file, and then load it into the max objects, and there you've got it. And from here, if we wanted to, we could use this map authoring to change the different nodes and edit it and resave it if you want to. But in general, I find authoring with a UI, with the mouse, is much more intuitive and much easier, especially for these very intricate maps. So that's the way I recommend that you work if you're designing maps for sound design. Download the free software, CueStation, rename it SpaceMap, go ahead and load it all up, and as a reference, if you want to, open up the example project that I provided in the package, and this has all of the maps, a huge list of maps, and then some more that I have included. If you don't want to look at the trajectories, you can say none, that I've included in the examples. And I've already converted many of them. Some of these are not in the examples. So there's a lot of examples of different maps, and you can play around with them, save them, export them, and import them into MIAP, and then use them for a variety of fun stuff. That's it.